All right, we have arrived at the last topic that we're going to look at in this module. In the previous module, Module A, we talked about piecewise defined functions, which was a little bit of a new topic. And this is going to be similar. These are going to be things that we've talked about previously, but we are going to approach it from a different perspective. And we're going to talk about transformations of graphs. In this particular video, we're going to talk about something called shifting. All right, so one of the drawbacks that exists when graphing different types of functions from scratch is that for each type of function, you have to remember lots of different techniques. Or we have to create tables, and we have to do a lot of computations. When we create our tables, we do want to create a comprehensive graph, and that is a graph that includes all key information. This includes points like intercepts and vertices. For lines, it includes slope. For parabolas, it includes direction. And all of these different types of graphs, we have to remember different techniques. On the other hand, when we talk about graphing using transformations, all we need to know is the basic shape, and then we are going to make adjustments. So we start off with the basic shape, we make adjustments to the original graph to create a new one. There are three basic types of transformations. And the first one we have is shifting. And basically what that entails is just moving the entire graph vertically and or horizontally. And so for instance, I can take this presentation and I can go ahead and move it this way or this way or this way or this way, but it stays the same. That is what we mean by shifting. The second one that we have, and we'll look at this in the next section, is going to be stretching or compressing. I call it compressing, the book calls it shrinking. And what this entails is we are going to stretch or we are going to shrink. Okay. Now when we do this, it's going to be kind of like Stretch Armstrong, which was a toy in the 70s that basically you took his arms and you could pull him apart this way, or you could grab his head and feet and you could pull him apart vertically. And so that's what we do when we talk about stretching or shrinking. And the last thing that we have is something called reflecting. And reflecting, what this entails is we're just going to flip the whole graph over the X and or Y axis. And so basically when we talk about reflecting, when you think about your reflection, if you are looking in a mirror and you raise your right hand, if you think about it from your reflection standpoint, they are raising their left hand. And so that's kind of what we talk about when we talk about reflecting. All right, so we want to talk about our basic functions that we are going to be working with. And so the first one that we have is going to be our constant function. This is a basic function, but keep in mind that we're really not going to play around with this one very much. It's not a very exciting function. And so, but it does exist in terms of our basic functions. The next one we have is our identity function. This is the basis for all linear functions. All linear functions are of the form f of x equals x. And all of those things that we do to it, slope, y-intercept, those are all just basic changes to this basic function. The third one we have is absolute value function. And when we talk about the basic absolute value function, this is just going to be absolute value of x. This is a V shape, nothing special, with its bottom point at the origin. We're going to play around with this one quite a bit in this section and the next section because it is one that's pretty easy to manipulate. The next ones that we have is we have our quadratic function. We've played around with this a lot. And just a reminder that a quadratic function is going to be x squared. That's our basic one. And again, everything that we add on to it just alters this basic shape, moves it, whatever, in some way. We'll play around with this one a lot in these two sections as well. The next one we have is the square root function. And the square root function is just going to be square root of x. It is the top half of a parabola laying on its side. And then the other ones that we're going to play around with is going to be the cubic function. This kind of has a snake shape that looks vertical. It goes through the origin. We also have the cube root function, which is that same snake shape, except for it's going to be kind of a horizontal snake shape. And so we'll play around with that one as well. All right, so now, as I mentioned, we're going to be talking about shifting a graph in this section. And whenever we do anything, we have two basic categories. We are going to have vertical, and as I mentioned in here, we're going to do shifts. And we have horizontal. Now, in general, when we talk about vertical, this is always going to be outside of our function. So our basic functions that we looked at previously is that basically we want to do things outside the square, outside the absolute value, outside the square root. And so the notation that we're going to have is we are going to have our basic function, our x squared, our absolute value of x, our square root of x, and then we do something on the outside of it. So for instance, adding k or subtracting k. When we talk about this visually, what this does is it is vertical, which means that we are going to go up and down. So if it's a plus k, we want to shift the graph up k units. And if it's a minus k on the outside, we shift the graph down k units. If we talk about this from the table perspective, what we are doing is we are adding k to all of our y coordinates. Remember, the y coordinates are the ones that go up or down. And if we are subtracting k, or if it's a minus k, if we're shifting down, then we subtract k from all the y coordinates. When we talk about vertical whatever, we do exactly what it says. If it says add, we add. If it says subtract, we subtract. All right, that takes care of vertical. Now, the next one we're going to talk about is horizontal. And horizontal is going to be inside the function. Notice here that our numbers, our k's, are inside with the x. And so, for instance, x squared plus 2 is on the outside. On the other hand, if I have x plus 2 in parentheses squared, I have to do my I have to do what's inside before I square the thing, and that's considered a horizontal. Now, horizontals are always going to be the opposite of what it tells us to do. So if you recall, when we talked about vertex form is actually this concept right here, is we are talking about taking our basic function and shifting it. And so, for instance, remember when we talked about vertex form, we did the opposite of what was inside, and we kept the outside number. Same thing here when we apply this to any type of function. We always want to do the opposite on the inside. And so, for instance, if we have f of x minus k, we want to not go in the negative direction. We actually want to go in the positive direction. And because it is horizontal, my positive direction is going to be to the right. If it is a positive number on the inside, I don't want to go in the positive direction. I actually want to go in the negative direction. And we go to the left. And I'll explain why as we do some of these problems. Now again, remember these are horizontal. And so what that means is in terms of our table, what we want to do is if it says x minus k, I actually want to add k to all of my x coordinates. And if it says x plus k on the inside, we actually want to subtract k from our x coordinates. Okay, so we'll do some examples of this as we get into some actual problems. But why do we do the opposite of what it says? So when we look at a problem, and let's just say we have our function, and let's say that it says f of 5 is equal to 8. So what this basically says is when x is 5, y is 8. That's what function notation means. But here, what we're looking at is I want to know if we have x plus 2 on the inside, what we need to figure out is when is x plus 2 equal to 5? And in order to determine that new x value, we have to subtract 2 from both sides in order to get x equals 3. And so basically, what we're looking at is, okay, that inside number, just like when we solved absolute value equations, when is that inside thing equal to what I want it to be? And in order to figure that out, we have to solve a little mini equation. All right, so in order to go ahead and do these, we're going to go ahead and talk about this from table perspective and graphing perspective. And as long as it is recommended that you play around with both and double check your work. And so we're going to go ahead and start by creating a table and graph for the original function, for our basic function. And this is sometimes called the parent function. From there, we want to adjust the values based on the transformation rules. Now, as we go through these problems, I'm going to be kind of making notes off to the side, and I do recommend doing this on your own because it does help you kind of sort through what we're doing. Okay? All right. Let's go ahead and start looking at some problems and kind of see how this works. All right, we're going to go ahead and start by looking at vertical shifts. And so in order to do this, we're going to start by creating a table for our parent function. And so if we start with our parent function, which is going to be x squared, we want to talk about, okay, what are the values that we want to plug in? So the ones that we're going to use for x squared is we're going to go -2, -1, 0, 1, and 2. This is going to be, remember that our parent function is a parabola starting at the origin. And we do want left and right side of this parent function. And so if we square -2, we get 4. If we square -1, we get 1. And for the other numbers, we get 0, 1, and 4. All right, we want our new function. And I'm going to do this two ways here. The first one is I'm going to actually compute it, and then we're going to compare it back to our parent function. So again, we're going to plug in -2, -1, 0, 1, and 2. And here, if we start by squaring -2, we get 4. We add 2 onto that, and we get 6. We're going to go ahead and plug in -1. If we square -1, we get 1. We add 2 onto that, and we get 3. All right, if we plug in 0, we get 0 squared is 0 plus 2 is 2. If we plug in 1, we get 1 squared is 1 plus 2 is 3. And finally, if we plug in 2, we get 2 squared is 4 plus 2 is 6. All right, now, if we go ahead and compare our original function to our new function in terms of tables, let's see what we got. Notice here that when we look at our x values are the exact same in both of these. And it's because we haven't done anything to our x values. But when we look at the y values, notice that what we have here is 4 becomes a 6. We added 2. 1 becomes a 3. We added 2. 0 becomes a 2. We added 2. And same thing with all of these. All we're doing is we are adding 2. And you may sit there and be like, well, then, what's the point? Well, keep in mind that we're just doing one thing right now. And so it really doesn't matter at this stage. But when we start combining this with other transformations, what we can do is we can start with our parent function, and then we're going to change either our x or our y's, depending on what we want to do. All right, so now let's go ahead and graph this. I'm going to start with my parent function. And so my parent function, we're going to go -2, -4, -1, 1, 0, 0, 1, 1, and 2, 4. We get something that looks like this. Now we've talked about what this +2 does in terms of our table, but what we want to do now is we want to talk about, okay, what does it do visually? And so visually, what this does is we are going to do a vertical shift, and we are going to go up 2. And so what that means is I take my whole graph, and I'm going to do this with my points. I'm going to move all of these points up 2. Every single point on our graph moves up 2. And so notice that when we compare these points, we get -2, 6, -1, 3, 0 goes to 2, 1, 1 goes to 1, 3, and 2, 4 goes to 2, 6. And so that's how we're doing this. And so when we connect our dots, we basically take our whole graph and we are shifting it up 2. All right, let's look at one more. If we come down to example B, we have the square root of x. And so we want to start again by creating our parent function. For a parent function for square root of x, we're going to start with 0, 1, and 4. I want numbers that we can take the square root of. All right, if we take the square root of 0, we get 0. If we take the square root of 1, we get 1. And if we take the square root of 4, we get 2. Okay, when we graph this, we have 0, 0, 1, 1, and 2, 4. All right, when I look at my new function, my minus 3 is on the outside. My square root ends right after the x. And so this is a vertical shift. Because it is negative, we are going to go down 3. And so I want to take all of my points and move them down 3. So we're going to come down here. If I take my y coordinate of 1, I go 1, 2, 3. We end up here. And my last point, if I go down 3, 1, 2, 3, we end up here. Okay. All right, when we look at our table, let's see what happens. We have x and g of x. And so, again, I'm going to go 0, 1, 4. And if I plug in, I get the square root of 0 is 0. Minus 3 is negative 3. Get the square root of 1 is 1. Minus 3 is negative 2. And the square root of 4 is 2. Minus 3 is negative 1. All right, so when we look at these, my x values are the exact same thing in both tables. And when we look at our y values, we are subtracting 3 each time. So x's stay the same. And my y values, we subtract 3. All right, let's go ahead and, so this is vertical shifting. Let's go ahead and talk about horizontal. All right, so with horizontal, again, we want our parent function. And just like before, for x squared, we're always going to do negative 2, negative 1, 0, 1, 2. When we square each of these numbers, we get 4, 1, 0, 1, 4. Now, what we have here is we have our subtracting and adding is inside our function, which means that it's affecting the x values. And so when we look at this, what we want to do is I want to know what we're going to do with changing our x. And so just to kind of give you an idea, I know negative 2 squared is equal to 4. And so what we want to do is we want to ask the question, okay, when is x minus 2 equal to negative 2? Well, in order to solve for x, we add 2 to both sides and we get x equals 0. And so when x is 0 and we plug it into g of x, we get negative 2 squared is 4. And we want to do these for each number. And so if we go, I know that when x equals negative 1, or when we know negative 1 squared equals 1, and so I want to know when is x minus 2 equal to negative 1. We add 2 to both sides, we get x equals 1. And so when x equals 1, we get 1 minus 2 squared is negative 1, and negative 1 squared is 1. Let's do one more. We know when 0 squared is equal to 0. And so I want to know when is x minus 2 equal to 0. Again, we add 2 to both sides and we get x equals 2. And so when we plug 2 into g of x, we get 2 minus 2 is 0. 0 squared is 0. And so now if we look at what we're doing here, notice that what we have is negative 2. We're changing it to 0. We're adding 2. Negative 1. We're changing it to a 1. We're adding 2. 0 to 2, we're adding 2. And we're going to do the same thing for the other ones. And so let's follow our pattern. When we add 2 onto 1, we get 3. If we add 2 onto 2, we get 4. And when we look at our y values, notice they're staying the same. We have a 4, stays a 4. 1, stays a 1. 0, stays a 0. And so we'll follow that pattern, and we're going to get 1 and 4 for the other ones. All right. Now, when we talk about visually, what are we doing? Because our minus 2 is on the inside with the x, this is going to be a horizontal shift. Now, when we talk horizontal, we always do the opposite of what it says. And so here, since it's saying minus 2, I want to do the opposite. Minus 2 is going to the left, and what we actually want to do is the opposite. We want to go to the right. So when we look at this vertically, or when we look at this visually, we have our parent function again. We have our x squared. It's a parabola at the origin. And we want to shift all of these points to the right too. So we're going to go this one, we're going to go to the right 2. This one, we're going to go to the right 2. This one, we want to go to the right 2. The blue point, we're going to go to the right 2. And this one up here, we're going to go to the right 2. And what we end up with is a parabola that looks like this. And if I was a better artist, it would look better. And if we look at our points, what are the points on this new graph? We have 0, 4. We have 1, 1. We have 2, 0. We have 3, 1. We have 4, 2, which is exactly what we got when we looked at our table. For these, I do want you to practice creating the tables, but notice that we don't have to. As long as we have our parent function, we can move the function as we need to. All right, let's do one more. Our last one, we're going to revisit our square root function. And so we're going to again start with our parent function. Remember, for square root, we start with 0, 1, and 4. And when we take the square root of these, we get 0, 1, and 2. All right, we have inside our function, notice this time my plus 3 is underneath the square root, which means it is inside the function. It is going to be a horizontal shift. Plus 3 would go to the right, but because it is horizontal, we want to do the opposite. And so we are going to go left 3. And in terms of our table, what this means is I want to take my original x values and I am going to subtract 3. And so if we create our table, we go 0 minus 3 is negative 3. We have 1 minus 3 becomes negative 2. And we have 4 minus 3 becomes 1. We don't have anything on the outside of our function, and so all of our y's are going to stay the same. So we're going to get 0, 1, and 2. And if we check this, if we plug in negative 3, we get negative 3 plus 3 is 0. Square root of 0 is 0. If we plug in negative 2, we get negative 2 plus 3 is 1. And the square root of 1 is 1. If we plug in 1, we get 1 plus 3 is 4. And the square root of 4 is 2. All right, so now if we go ahead and graph these, we have our parent function is 0, 0, 1, 1, 4, 2. We get our square root graph. If we shift these points 3 to the left, we're going to be at negative 3, 0, which is what we have on our table. We have negative 2, 1, which is on our table. And we have 1, 2, which is on our table. And we get something that looks like this. And so notice here that what we've done is we have basically moved our entire graph 3 to the left. All right, so this is our horizontal shifts. The next thing that we're going to do is we're going to do some where we have both. And in terms of computing, it gets a little bit harder when we start plugging in our numbers because now we have to think about, okay, we got to simplify the inside, then we have to apply the function, and then we have to apply what's on the outside. But when we approach this from transformations, what we're going to do is just look at how are we changing our x's, how are we changing our y's, and they're kind of completely separate from each other. So let's go ahead and look at some examples of that. All right, let's do a combination problem. And so for this one, we're going to work with absolute value. And so for absolute value, again, our parent graph, we are going to start with the same ones that we use for the quadratic function. So we're going to go with -2, -1, 0, 1, and 2. But the difference is when we take absolute value, remember that we just make it positive. And so the absolute value of -2 is 2. The absolute value of -1 is 1. And then the other ones we keep the same because they're not negative. Okay, for this one, instead of doing computations, I want to go ahead and talk about this in terms of transformations. And we're just going to make the changes that we want in our table. All right, so the first thing that we have is inside my absolute value, I have a +3. And so what this means is this is a horizontal shift. We do the opposite of what it says. So we're going to do our x's -3, or visually, we are going left 3. And so when we look at our table, what we're going to do is we're just going to subtract 3 from all of our x's. If we start with -2, -2 minus 3 is -5. -1 minus 3 is -4. And we repeat this for all of them. 0 minus 3 is -3. 1 minus 3 is -2. And finally, 2 minus 3 is -1. That's what we're doing to our x's. The other thing that we want to look at is we have on the outside of our function, we have a +2. And so this is going to be a vertical shift. Remember, vertical, we do exactly what it says. And so we are going to take our y's and add 2. Visually, we are going to go up 2. And so when we do this, we're just going to take the y values in our table and add 2. So we get 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. And we have 1 plus 2 is going to be 3. And finally, 2 plus 2 gives me 4. And so what we essentially have here is my x's. Again, we're adding 3. We do the opposite. My y values. We do what it says, we add 2. All right, so let's look at this visually now. So we're going to start with our parent function, which is a V shape. And we get that it looks horrible. We should get that it looks like this. Okay, that's a little better. Okay, now if we want to talk about this visually, okay, let's see what we do. This tells me I want to move all of my points left 3 and up 2. So when we do this, let's start with our leftmost point. We want to go 3 to the left and up 2. So it's kind of like when we talk about slope. And we do that for every single one of them. We go 3 to the left and we go 2 up. And what we end up with is the exact same shape, but it's going to be right here. You don't have to draw all these arrows on your graph, but it just kind of is meant to show you visually what are we doing. And if we look at this, do we have the same points that we got in our table? We do. My leftmost point that I have plotted here, we are going 5 to the left and 4 up. My second one, we are going 4 to the left and 3 up. My third one, we are going 3 to the left and 2 up. And so this is what we get for this graph. Okay, now not only can we graph these, we can also create functions using transformations. And so that's what we want to look at now. Again, we're just going to focus on shifts. All right, we are going to be given a parent function, and then we're going to be given some things that we want to do to it. So the first thing that we have here is we have our parent function is going to be x cubed. We have 2 things that we want to do to this. We want to do 3 units to the right, and we want to go 5 units down. So I'm going to break down each one of these. And so let's start with the 3 units to the right. All right, if we go 3 units to the right, this is horizontal. Remember, horizontal is always inside, and we do the opposite. So 3 units to the right, we're adding 3, but inside my function, I want it to be subtract 3. So when we start writing this function, we do want to use a different function name. I'm going to start with my parentheses, and I've got my cubed on the outside. And so here I want to go not x plus 3, but minus 3, because we are doing the opposite. All right, the second thing that we have going on is we have that we want to go 5 units down. And so 5 units down, this is vertical. This is going to be outside, and we do what it says. We don't do the opposite. And so if we're talking 5 units down, we're talking about subtracting 5. And so that's what we're going to put on the outside. And so my final function is going to be g of x equals x minus 3 cubed minus 5. And we're done. All right, let's look at one more. And so we are going to start with a parent function of f of x equals the cube root of x. We want to go 2 units left, and we want to go 4 units down. All right, so we're going to start off with our parent function. We have f of x. I'm going to do cube root of x, and we'll leave it like that. Okay, so now let's talk about our transformations. We have 2 units left. This is horizontal. This needs to be inside. And we do the opposite. And so when we talk about moving 2 units left, we're talking about subtracting all of our x's by 2. But we want to do the opposite. And so inside our function, we are going to have x plus 2. The second part of this, we want to go 4 units down. This is vertical. It is outside. And we do what it says. And so 4 down means I want to subtract 4. And so outside my cube root, I'm going to have minus 4. And we're done. All right. This is our first part of transformation, which is talking about shifting. We are now, in the next video, in the next section, we are going to talk about the other transformations we have, which is going to be our stretching, compressing, and reflecting. And so I will see you again soon when we discuss that one.